Resonance structures. The concept of resonance structure is very important in chemistry, especially in organic chemistry that many of you will be taking later. So first, what are resonance structures? Resonance structure are basically the same molecule, but they have different way of arranging their electron. So, how can a molecule have different way of distributing their electron? The answer is because of how the double bonds may be formed in a molecule. So a molecule will have different way of distributing its electrons to form the different double bonds, and those are called the different resonance structure. And overall, if a molecule can make more resonance structure, then it tends to be more stable. So that's very important in chemistry. So let's go over an example of the different resonance structure. So here in this case right here, we have NO2 plus, and we've been told in here that there has two different resonance structures. So let's draw them. So first of all, following the step how to draw Lewis structure, we would have to calculate first the total number of valence electrons. And here in this case, we have one nitrogen, and we know nitrogen have 5 valence electrons. And we have 2 oxygen, and each oxygen has 6 valence electrons. And here in this case, we do not forget to subtract 1 because of the positive 1 charge. So here in this case right here, we would then have 16 valence electrons altogether. So that is the first step. The next step is to determine the central and the terminal atom. So here in this case, it should be obvious that nitrogen is the central atom, and the 2 oxygen atoms are then the terminal atom. So let's connect them together. So we're going to put nitrogen first, followed by the 2 oxygen connecting to the nitrogen. So that would be our skeletal structure. And so far, we have used up 4 valence electrons of the total 16 to form this skeletal structure. So subtracting 4, we would then have 12 valence electrons remaining. And with the remaining 12 electrons, we're supposed to complete octet for the terminal oxygen first. So here in this case, both of the oxygen, it would be needing 6 more valence electrons to complete the octet. So we're going to give 6 to this oxygen and 6 to this oxygen, and that all of the valence electrons that we have remaining. So here in this case, subtract 12, we have 0 valence electron remaining. So thus, we do not have any lone pair electrons to give to the central nitrogen. And the next step would then to be moving the lone pair of electron from the terminal atom toward the central nitrogen to give the octet to this nitrogen, because this nitrogen right here do not have the complete octet. So here is the part right here that will allow us to draw the resonance structure. How many ways and in what way can we move the lone pair of electrons from the terminal atom to the central nitrogen to complete its octet? So here in this case right here, we know that the nitrogen will need 2 more pair of electrons to form double bond to it to give it the complete octet. And therefore, we may have different way of doing that. One way is by taking both pair of electrons from the same oxygen and move them to the nitrogen. Or the other way would be to be taking 1 pair from this oxygen and the other pair from the other oxygen. So now let's draw them both. So in first way, method A, in one we be moving 1 lone pair each from each oxygen. So here in this case, we're going to move 1 lone pair from this oxygen and the other pair from the other oxygen. And the structure that we would now have will be as follows. And here in this case right here, anytime that we are showing resonance structure, we would be drawing this double-headed arrow right here. So this structure right here will be one of the resonance structure. The other resonance structure is the other way that it is possible that we can move the lone pair of electrons to form the to give the octet to the central nitrogen. So here in this case right here, we can either take one of the lone pair from one oxygen and the other lone pair from the other oxygen. So that would be another different way how to give the central nitrogen two pairs of electrons to complete its octet. So in this case right here, it does not matter which oxygen that we do it, it would still be the same answer. So the resultant structure following the set of arrows in green would be as follows. And the other oxygen still have its two lone pair of electrons. So these are the two ways, way A and B, that we can move the electrons from the terminal atom to complete the octet for the central nitrogen. Thus, these two structures right here would then be the resonance structures. So these are resonance structure. And to show this two molecule resonance structure, we will be using this double-headed arrow. And now, lastly, don't forget to put in your formal charges. So here in this case, if we were to apply our formal charge equation, we would then see this oxygen is positive 1, this nitrogen is positive 1, and this oxygen is negative 1. And its overall charge would then be still positive 1, which exactly is the overall charge that we have seen here previously. And again, applying formal charge to the other resonance structure, we see this oxygen would then be neutral. This nitrogen right here is positive 1, and this oxygen right here is neutral. So in this case, the overall charge is also positive 1 as well. So there you go. These are the two resonance structures. So again, the step that will help us draw the resonance structure will be this step right here. Basically, how many different ways can we move the electrons to the central atom to make the central atom octet? For each way that is possible, it will then produce one resonance structure. So here in this case, these are the two possible ways giving rise to this two resonance structure right here. So it is not in the scope of this class right here to determine which of these two resonance structure would be more stable. But later on, as you move on to more chemistry classes, you will learn how to make assessment of whichever resonance structure would be more stable.